So I'm going to go through this test, given that we don't have time to go through every test in class, and I'm going to do what we call a think aloud as I go through the test. So I'm the student, and I'm thinking about all of the things I need to understand and know in order to solve each of these problems. Listen carefully, take notes, go through the test as I do it so that you can really understand what's going on and why. If you have a question about something or you're not sure what I'm talking about, stop the video, make a note, and then come to me and see if we can't get that answered, or have your parents watch it with you, have someone else watch it with you that can help you interpret what's going on. I put my name on my paper. Our long-term learning target for the Unit 2 quiz is I can solve practical problems through application of my knowledge of linear equation. So we're going to take the knowledge we've been learning and we're going to use linear equations to solve problems. That's something key to remember, and I'll get back to that and refer back to that several times. Please follow all instructions carefully. Okay. Problem number 1 says the sum of two numbers, a and b, is 87. Before I go on at all, I look at that and think, the sum. What does the sum mean? Well, sum means addition. So two numbers being added together are going to equal 87. So I'm going to write right off the bat, before I finish reading these instructions, I'm going to carefully write this one down. A plus b, the sum of two numbers, is equal to 87. Because equal means equal in mathematics. We need to be aware of that. Remember that. Okay, good. I feel pretty comfortable with that. The difference between two numbers is 39. Well, what does difference mean? Well, difference means subtraction. What's the difference between two numbers? We're not talking about the language arts definition of difference, like, Gary looks different than Linda. There's not a number we can put on that. The difference for this is literally a subtraction problem. The difference between the two numbers, meaning the same two numbers we're talking about, is 39. So that would mean that a minus b is equal to 39. Now, the key here is to understand that we're talking about the same set of numbers. The sum of those two numbers is 87, and the difference between the same two numbers is 39. So a is going to be this a is going to be the same as that a. It can't be two different numbers. And this b is going to be the same number as that b. Can't be two different numbers. They're the same thing. All right? So I've got these two equations written down, and now I'm going to read the next instruction. It says write two equations that represent this scenario. Ha! I've already done it. There's the first one, and there's the second one. I've already written those two equations, so I'm set and I'm happy. Now I'm going to use these equations to find the two numbers a and b. If you didn't use these equations, I shouldn't give you full credit, because it says to use the equations. And the reason this is important and valuable is because even though some of you figured this out without using the equations, this is one of the easiest problems you can do using linear equations. As you get into the more difficult ones, there's no way you can see the numbers and guess what they are. A guess and check is no longer going to work for us. So we need to learn how to use these equations. In this particular case, I'm going to do it two different ways. The first way I'm going to do this is by elimination. I've come to understand that I can stack these equations on top of each other and then simply add them together just like I would in an addition problem. All right? I have to make sure when I add them together that one of these variables is eliminated, because I can't solve either one of these equations for a or b and get a number if I have two variables. So I have to eliminate them. That's why we call this the elimination method. So here we go. I notice that this positive b is exactly the opposite of this negative b, positive 1b and negative 1b. So if I add these two equations together, it will eliminate those b's. A plus a is 2a, and b plus a negative b is 0. and that equals 87 plus 39. 9, 10, 11, 12, 13, 14, 15, 16, 8, 9, 10, 11, 12. Okay, and I look at that and realize I don't even need that 0 there, so I rewrite it as 2 times A equals 126. Voila. Without needing to really do a lot of thinking about this and guessing numbers and checking numbers and trying to figure out what they are, I'm going to be able to use this equation to spit a number out for A. If 2A's is 126, then 1A is half of 126. Or, if I divide both sides by 2, 126 divided by 2, which means A is equal to 63. Now that I know what A is, I can take that A and substitute it back into either one of these equations to get B. So, if A is 63, I can write for this equation 63 plus B equals 87. Now I can solve for B using this equation. If I subtract 63 from both sides, I get B equals 4, 2, 24. Well, that's pretty slick. A is 63, B is 24. I can test that by saying 63 plus 24 equals, if it's equal to 87, then I'm good. 60, 70, 80, 4 plus 3 is 7. Check. And now 63 minus 24 should equal 39. 60 minus 20 is 40. 3 minus 4 is a negative 1. 1 less than 40 is 39. Check. And that's one way of solving this problem. The second way is by substitution. Once again, I look at this and say the sum of two numbers, A and B, is 87. Okay, A plus B equals 87. The difference between the two numbers is 39. A minus B equals 39. And if you went this far, I gave you 2 points anyway, regardless of whether you solved it completely or not, because you understand you need to create those equations and use them. Now I can do this by substitution. I can solve one of these for A or B right off the bat. It's not going to give me a number, but it will give me something for A or something for B. I'm going to choose to solve this bottom one. If I add B to both sides of the equation, I get A equals 39 plus B. See, I didn't get a number. I have something involving B over here, but I know what A is. So I'm going to take that A and I'm going to substitute it into the other equation. And that's going to give me 39 plus B, that's the A, right there, plus B equals 87. Now that I've done that, once again, I only have one variable here. It's in two places, but it's only one variable. 39 plus B is plus 2B equals 87. Now I can subtract 39 from both sides. Once again, we're trying to get B by itself. We do this all the time. And I get 2B is equal to 87 minus 39. 87 minus 39 is, let's see, 8, 7, 17, 8, 48. 2B is equal to 48. If 2B is 48, then half of 2B, or B, is equal to half of 48, which is 24. In other words, divide both sides by 2, and I get B equals 24. Now that I know what B is, I can come back up here into this one, or this one, put B in, and solve for A. I've decided, since I already have A equals here, I may as well just write A equals 39 plus 24, and I get 3 plus 2 is 5. 9 plus 4 is 13. 50 plus 13 is 63. A equals 63. Once again, I can go through and test that. I've already done the test, so I'm not going to do it again for you. Two different ways of solving a set of simultaneous equations. Elimination and substitution. Pause this video at any time and you can sit here and study these things.